Hello all, welcome to the class. In today's video, we understand a program to show rotation, scaling and translation of an image. The main purpose of this program is to read an image, rotates it by user specified degree, scales it by a user specified factor, and then translate it horizontally as well as vertically by user specified distances. Finally, it saves the produced image in a file. This sequence of operations can be useful for various image processing tasks such as data augmentation or creating specific visual effects. Let us move on to the program. So here we start with importing necessary libraries. So we'll start with here import as usual CV2, then moving on to rotation and scaling of an image function. So we have used a function over here to translate the image. So for this, the parameters what we use is image to be passed along with a dx and dy values. So here this translate image function defines a function to move or translate an image horizontally and vertically. Translating an image can be useful for shifting the position of the image content within the frame. So here we have a value called row and columns to be extracted. Again same thing, rows and columns of the 2D matrix is obtained by what? By a shape function. The same thing what we discussed in the previous program. So this gets the number of rows, that is called as height, and the columns, that is called as width of the image. This gets the height and width of the image, and knowing the image dimension is very necessary or essential thing to create the translation matrix and apply the transformation. So we are applying dot shape method over here. Next, moving on to next line, the translation matrix. So how are we obtaining this? By making use of dot float 32. What exactly that this function does is, each value in numpy array would be a float of size 32. That is the meaning of this, and this creates a translation matrix that specifies how much to move the image in the x direction, to move in the x direction as well as in the y direction. So x is, that is dx and dy. This matrix is essential for performing the translation. Next, moving on to dot wrap affine. What exactly this function does here is, this applies the translation to the image using the translation matrix what we have discussed earlier, and this performs the actual translation operation. This is going to perform actual translation. Then finally you have to return what? Return translated image. Once the computation is done, return this. So after doing this main calculation for translation, let us read image from the specified path. You have to store your image where exactly you are performing the program. In the same folder you can keep the content and keep that path over here and read the image. Then we already know that for obtaining the height and width of the image, we need to make use of dot shape function as discussed earlier. After finding that, we need to also calculate the center coordinates of the image. Why the center coordinates are considered here is, it's actually treated as a pivot point for rotation. So this helps to maintain the visual balance of the transformed image. So that's why you need to calculate the center point of the image. So how do you obtain the center point of the image? We have already discussed in the previous. So center point is this. This location can be fetched by half of the width as well as half of the height of the image. So that is going to give me center of the image. Next thing is, after doing this, we have to receive input from the user for about what a degree of rotation they require as well as zooming factor. So receive them, then pass them value and create the 2D matrix. So how do we create the 2D matrix? Actually these two lines allows the user to give how they want to transform the image. Next, moving on to create the 2D transformation matrix just by taking what? A function called get rotation matrix 2D. So this is what the function. So what are we trying to do here is, we are creating a matrix for rotating the image around its center by rotation value. So what is that rotation value the user is giving? Angle. You are receiving the angle from the user. So rotation value degree without changing its size, without changing its scale size, because we are specifying scale as 1. Next, moving on to get rotation matrix 2D for scaled. Here in the previous we had done rotation and we have to do the scaling here. This creates a matrix for scaling the image around its center by scaling value. The scaling value is the scale parameter which takes the value from the user. The angle is set to 0 because we are only scaling, not the rotation. So that you can observe here, angle made 0. In the previous case, scaling was fixed and we were doing with respect to this. After doing both, we just move on to dot wrap affine function, which helps us to actual rotation. For doing actual rotation, you should finally apply dot wrap affine. Is done with the help of the dot wrap affine function, actual rotation. Then moving on to next, reading h value and v value from the user. So what is this h value and the v value? You have to ask the user to give horizontal rotation, how much they have to do, and vertical rotation. So we just labeled it as h stands for horizontal, v stands for vertical. So after reading these two values, we have to translate the image, translated image, by this, call the function. Okay, so call the function to move the scaled image by h pixels horizontally and v pixel, h and v pixel vertically. We are just passing those values in order to perform the translated image. After this, we have to just print that using IamWrite function. So if this is not working, you can make use of the previous concept without using the CV2 object. You can also plot it. You can also try that. Final image and the translated one. Save the file as translated image to a file name called the final image, and you can see that image how it looks. So your input was the same image which I had taken the in the previous program, and the one sample output which I have done is enter the degree of rotation 90 degree we tried, then enter the zooming factor 5 zooming factor was given, horizontal pixel was 10 and 20 pixel. So you can see the result like this, the final image. Then in the second output I tried with a different value in order to understand whether it is performing the task properly or not. 45 is been considered. You can also notice that image has been translated or rotated 45 angle. Then enter the zooming factor was same as fixed to 1. Then horizontally 100 pixel, vertically 100 pixel. By giving all this data, we were able to obtain output like this. I hope you understood the whole program. Thank you.